In this lesson, we're going to continue to answer the question, how do I use the distributive property to write equivalent expressions? Take a look at workbook page 197. Here you can see two examples where you can apply the distributive property to just part of an expression, just part of it, to write an equivalent expression. So take a look at example 1. Here you have 3 plus 2 times the sum of A and B. If you look very carefully, you see that 2 times the sum of A and B can be rewritten by distributing. Remember how we said that you can distribute by getting rid of the parentheses, or I guess when you distribute you're getting rid of the parentheses? You want to take the 2 outside the parentheses and multiply it with everything inside the parentheses. So 2 times A gives you 2A, 2 times B gives you 2B, and you bring your addition sign along for the ride. So now you can rewrite that original expression of 3 plus 2 times the sum of A and B as 3 plus 2A plus 2B. You can see the diagrams here show this. In this diagram you have the 3 plus 2 times the sum of A and B, because you have 3 here, and then you have A plus B here, and we have another A plus B there. So you have 2 times A plus B. Or you can rewrite it so that A's are together, A plus A or 2 A's, B plus B or 2 B's, and now you have 3 plus 2A plus 2B. Look at example 2. Here we have 3A plus 2A plus B. So this time we don't see any parentheses in there, but if you look carefully, you notice 3A and 2A actually have a common factor, the common factor being A. In this case, you can pull out that common factor and rewrite the expression with parentheses. So pulling out the common factor allows us to put parentheses in. So now my common factor goes outside the parentheses, right here, and inside the parentheses are the 3 plus the 2. Which you can even simplify even further to be 5A plus B, because 3 plus 2 is 5 and 5 times A is 5A. Take a look at the diagrams. You can see they're almost identical. Here we have 3 A's plus 2 more A's plus B. So that's our 3A plus our 2A plus our B. That was the original expression. And then in the rewritten expression where we do 3 plus 2 times A, so A times the sum of 3 plus 2, that's going to give us 5 A's, so we just put all 5 A's together, plus the extra B. Okay, continuing on workbook page 197, look at example 1. Use the diagram to help you find a third expression that is equivalent to 3 plus 2 times the sum of A and B, and 3 plus 2A plus 2B. So this was the example 1. Let's see. What we could do maybe is to just break it up a little bit. Do you notice, like maybe down here in this example, oops, I'm moving this. In this example here, you've got 2 times A, you've got 2 times B. What if we were to break up the A's and the B's? What if we were to say 3 plus, instead of 2 times A, we can just say A plus A, because remember, multiplication is just repeated addition. So 3 plus A plus B plus B, because the A plus the A is the same as 2 times A, the B plus the B is the same as 2 times B. So maybe I can rewrite it that way, where I just expand out all of my addition. Okay. Now, looking at numbers 15 and 16, we're going to apply the distributive property to just part of each expression to write an equivalent expression. Model the equivalent expressions with diagrams. So now we're going to also come up with diagrams. If you look at number 15, I see parentheses in there. And when you see parentheses, look carefully, because you might see an opportunity to do some distributing. Here, I can take this 3 and I can distribute it to the C as well as the D. So that's going to be 3 times C plus 3 times D, and of course plus 6. So if I were to draw a diagram, let's see, my original expression was 3 times the sum of C and D. So maybe I'll do, here's C, here's D. I'm going to make another C and D. And here's another C and D. So that gives me 3 times the sum of C and D plus 6. And if I were to rewrite it the way I have it now, I can put my C's together. So 1, 2, 3 C's. And now I have 3 D's. And then, of course, the 6. So this is my 3C, this is my 3D, and of course my 6. So you can see that these two diagrams are exactly the same. They have the same number of C's, the same number of D's, and of course our 6 at the end. Number 16 now. I'm going to change my color. Let's go with red. 7 plus 2e plus 2f. I don't see parentheses in here, but I see an opportunity to put parentheses in by pulling out a common factor. And where I see a common factor would be right in this area here, 2e plus 2f, because 2 looks like my common factor. I can pull out that 2, so I can keep the 7 the same. I can pull out the 2, the common factor goes outside the parentheses, and inside the parentheses I can put the e plus the f. So now I've rewritten it so that I have parentheses in there by pulling out that common factor. So let's go back to the original expression, and we'll diagram that. 7 plus 2e plus 2f. Here's my 7 plus my 2e's plus my 2f's. So this is the 2e part, this is the 2f part. So 7 plus 2e plus 2f. Or, now with my new expression, I can keep the 7. 7 plus 2 times the sum of e and f. So here's E and F, and here's another E and F. So this is 2 times the sum of E plus F. I have E plus F 2 times. So you can see, again, these are equivalent expressions. They both have the 7, they both have 2 E's, they both have 2 F's. Now on page 198, we're going to talk about finding the greatest common factor. When we pulled out common factors, before, most of them were pretty easy to identify. Sometimes they're not always. And if you remember, we've talked about GCF many times before. You want to try and figure out the greatest common factor to pull out. And you can do that by listing out factors. So, for example, if I looked at 48 and 32, I can list out all the factors of 48, 1, 2, 3, 4, 6, 8, 12, 16, 24, 48. The factors of 32 are 1, 2, 4, 8, 16, and 32. And yeah, they have 1 in common, they have 2 in common, they have 4 in common, they have 8 in common, but the greatest number that they have in common is 16. So 16 would be the GCF of 48 and 32. And you're going to see how we can apply that to actually using that in some addition problems. Look at 63 and 54. Well, you could obviously add up 63 and 54 and get your answer. But you could also do this another way. Instead of adding, you can rewrite the problem using the distributive property. Take a look at 63. If I were to list out all the factors of 63, let's see, I've got 1, 3, 7, and 9, and a 3 times 21 is what gives you 63, and of course 1 times 63 gives you 63. So those are my factors of 63, and let's see, 54, factors of 54, 1, 2, 3, let's see, 6, 9, we've got 18, because 3 times 18 is 54, and 2 times 25, 2 times 27 gives you 54, and of course 1 times 54 gives you 54. So those are all my factors of 54. Now obviously they have 1 in common, they have 3 in common, they also have 9 in common. It looks like 9 is the greatest common factor here, and you can see that they've rewritten it here. 9 times 7 is what gives you 63, 9 times 6 is what's giving you 54. So they pulled out the common factor of 9, and I'm going to put 9 outside the parentheses, and I'm going to put 7 and 6, the other factors, inside the parentheses. So another way to rewrite this addition problem of 63 plus 54 is actually 9 times the sum of 7 and 6. Let's do the same thing for number 31. Let's just erase this, make some space here. We're going to list out all the common factors of our next addends. Oh, look at this. Our next, oops, I didn't mean to erase all of that. Again, that was, for the first one, 9 times the sum of 7 and 6. So for number 31, let's see, 7x is one of my addends, and 35 is the other one. I'm going to list out all the factors. Well, 7, the only factors for 7 are 1 and 7, obviously, because 7 is prime. And I'm still timesing that by x, so I would consider x a factor too. These are all the numbers I'd have to multiply to get 7x. And for 35, 1, 5, 7, and 35. And it looks like the greatest common factor here is 7. I know that 7 times x gives me 7x. I know that 7 times 5 is giving me 35. 7 is the greatest common factor. So I'm going to pull out that common factor of 7. I'm going to put that outside the parentheses. And inside the parentheses, I'm going to put the other factors, x and 5, and I'm going to put the addition sign in the middle. So 7 times the sum of x and 5. So here are the takeaways. You can apply the distributive property to part of an expression to write an equivalent expression. So that means that you may only need to use the distributive property just to certain parts of an expression. It may not be the whole thing. And the greatest common factor, of course, is the greatest factor that 2 or more numbers share. That should be familiar to you. And of course, you can pull out that greatest common factor of any two addends and rewrite it using the distributive property.